So after we calculating the torque value, shall we go with the formula of torsion equations. So the torsion equations we can able to calculate in the individual diameter. It's nothing but a solid shaft diameter. So that is the formula behind that. T by J is equal to tau by R is equal to C T naught divided by L. So in the particular given problem, the C value, the modulus of rigidity as well as the angle and length that will not be given. So you just ignore this. And now we can get in the value of torque. So we know the value of shear stress. So R is nothing but a diameter by 2. Clear? So among the three values, we can't able to calculate the polar moment of inertia. So the solid shaft of polar moment of inertia, J becomes 5 by 32 into d power 4. So directly applied with the formula, we can able to calculate the with respective of diameters. So what is the value of torque?
19 into 10 power 6.
19 into 10 to the power of 6 divided by 5 by d power 4 divided by 32 equal to what is the value of tau? Shear stress value 80 divided by R is nothing but a radius, so it is nothing but a d by 2. Clear? Now you can substitute in. So d power 4 d. So in uppercase means it can be cancelled. So d power 3 is equal to 19 into 10 to the power 6 into 32 divided by 5 into 2 into 80. So what is the value of d? So the torque value 106.5. It is the entire d value, not d cube value. So in terms of m. So could you now check it? The previous cell t is equal to pi by 16 into tau into d cube. So that also we are getting the same value. Or otherwise, you guys are equating the torsion equation like this. You are also getting the same answer. In the exam point of view, you guys are using any one of the formula to calculate in the solid shaft. Here, hollow shaft means we have the two diameters, inner dia as well as the outer dia. So this is the solid diameter, solid shaft diameter. So in the given problems, they given as inner diameter is equal to 0.6 of outer dia. So in the solid shaft, only the single shaft is there. So this is the final diameter of the solid shaft. So there is no need of to calculating the D1 like this 0.6 into this big. So you may not calculating this. Now we go with the hollow shaft. Am I right? So the same equation you can apply for this. Instead of the polar moment of inertia, what is the value become changes? J is equal to 5 by 32 into d1 power 4 minus of d2 power 4. This is the formula. Could you check it? Now you apply the same concept. So torque value means 19 into 10 to the power 6 divided by 5 by 32 into d1 power 4 minus d2 power 4 equal to tau 80 divided by d by 2. Now, how to calculate the individual d? Can anyone? How to calculate the d?
D is here. Mistakes of capital.
That's why I am asking. So this inner dia value is directly given as 0.6 d. So first you can calculate the polar moment of inertia separately. You getting the answer. After the answer only put in the above formula. So 5 by 32 is equal to d1 is given as 0.6 of capital D minus of times of capital D the whole power 4. How to summarize this? Okay, please make a note of it. Once again, so this is the inner dia. So you mention as IT OD. In case you have any mismatch communication means you can indicate like this. So with this relationship, we can take this 5 by 32 1 minus of 0.6 D1 power 4. So you multiply by 5 by 1, 5 by 32, what will be the answer?
0.08.
Answer into within a bracket 1 minus 0.6 power 4. What is the value?
0.08.
0.085 D1 power 4. So this is the polar. So this is the polar moment of inertia.